Okay, so now that we know a little bit about where the electrons are, let's talk about properties associated with elements and how the electrons affect that a little bit. All right, so we're going to talk about valence electrons and this thing called periodicity. Okay, so if we look at the electrons in the first three alkali metals. Remember, the alkali metals are the electrons, or excuse me, are the elements in the first column of the periodic table. So we're looking at lithium, sodium, and potassium. Now, if we look at lithium, lithium has 3 electrons, sodium has 11 electrons, and potassium has 19 electrons. And if we put those in the energy levels, we can see that nitrogen has 2 in the n equals 1 and 1 in the n equals 2. Sodium has 2 in the n equals 1, 8 in the n equals 2, and 1 in the n equals 3. And potassium has 2 in the n equals 1, 8 in the n equals 2, 8 in the n equals 3, and 1 in the n equals 4. Okay. We didn't do potassium, but you have to trust me with that. All right. So the green electrons in each diagram there are the valence electrons in that atom, or that element, and then the yellow ones are the inner core electrons. And we've said that the valence electrons are the ones that are associated with interactions with other atoms around them, and they're associated with reactivity and bonding and things like that. So for the first 3 alkali metals and for the last alkali metals, they all have 1 valence electron. So all the alkali metals atoms each have 1 valence electron. And because of that, their properties are very similar. Like we said, the alkali metals are all very reactive. They all are air sensitive. They all react with water violently. And the reason for that is because they all have this 1 valence electron. Okay, that property that we can predict properties of elements, properties of atoms based on their electron diagrams, or where their electrons are, is this thing called periodicity. And that's why the periodic table is the periodic table, and that's why we have these things called periods and so on, is that the elements in a column all are going to have similar properties and similar reactivity. And the reason for that is because of this fact that they all have the same number of valence electrons. All right, if we go a step further and we go to the second group, the second column, the alkaline earth metals, that's what they're called, and we look at the first 3 of those. Beryllium has 4 electrons, magnesium has 10 electrons, 12 electrons, sorry, can't add, and calcium has 20 electrons, and we put those in the energy levels. We can see that all the alkaline earth metals have 2 valence electrons. Again, because they have 2 valence electrons, they're going to have similar properties, they're going to have similar reactivity. We said earlier that the alkaline earth metals are still quite reactive. They're not as violently reactive as the alkali metals, but they're still very reactive. And they are very reactive because they have 2 valence electrons. Okay. If we go farther and we go to the halogens, which are the second to last group or column in the periodic table, those are going to be the very reactive nonmetals, and each of those are going to have 7 valence electrons. And then the last column, the noble gases, each of those have 8 valence electrons, and they're not very reactive at all. And there's reasons for that, which we're not going to delve into. But once you get to 8 valence electrons, you get a very stable atom that doesn't really want to interact with other atoms or interact with other electrons, so they're very unreactive. So that's kind of the fundamental understanding of what periodicity is, of how properties of elements are based on their electrons, and specifically their valence electrons, and why we can predict properties of elements simply based on where they are in the periodic table. It's because of their electrons.